The whiteboard explanation for experiment 12, which is basically get it, acids and bases, and the red cabbage. So next time you cook a red cabbage, you can save the liquid. The liquid is an acid-base indicator. And so you've worked with indicators a little bit. We worked with phenolphthalein. So indicators, you could even do this lab at home if you wanted to. That says indicators are substances that give us an indication, but typically that change color in response in the presence of certain chemicals. And there's a million of them. There's tons of them. In this lab, the chemicals are acid and base. So what you want to realize, and so in this case, when you boil a purple cabbage, the water, the blue water that you get is an acid-base indicator. And you can do this at home and look at some stuff that's under your sink, some household cleaners, and see what color it turns. And you can even use the data from this lab to help you say what the pH is, because the data that I'm sending you is actual data from the experiment that we don't actually get to do. In this case, we're dealing with acids and bases. And acids form this ion. Those of you in the lecture, I did a little bit more rigorous treatment of it. Bases, which is also called alkali, form the hydroxide ion. And what happens is that typically we measure acids, bases in terms of pH. And the reason we can do that, so pH is the negative of the logarithm of the H plus concentration. And this means H plus, this means concentration. Concentration is like parts per million. We did that before. The one we use typically is what's called molarity. And we're not going to get into what molarity is in this lab because it's not terribly important. Just realize it's a concentration unit. It's the amount of H plus over the volume of the solution. Right? So the reason we can use H for hydroxide is that hydroxide will react with H plus to form water. And since there's always both of these in water, the hydroxide will react with the H plus, so the hydroxide will affect the H plus. And the bottom line is, if you look at the math here, if the higher this number gets because of the negative, this gets lower. So acids have pHs below 7. Bases have pHs above 7. Also, it's a log scale. That means for every number, it's actually 10-fold. To do the math, let's say that I had you just use the log buttons on your calculator. So if I had, let's say, my H plus is 0.01, which for those of you like scientific notation, 10 to the minus 2. Then the pH would be the negative of the log of the H plus, which is the negative of the log, in this case, of 0.01. And you can do this on your calculator. And that's going to be 2. All right. You can do this backwards. Let's say if the pH equals 3, let's say the pH is 3, that means 3 is the negative of the log of the H plus. And so then you would say negative 3 is the log of the H plus. And so then the H plus, depending on your calculator, would be the anti-log the H plus. And again, calculators will either have an anti-log or a 10 to the X key, 10 to the, H plus will be anti-log of, in this case, -3, and this would be 10 to the -3. That was a mistake there. Right, so the anti-log is the way you do log. On your calculator, you either hit the 10 to the X key going backwards, right? And so really all you're going to do in this lab is you're going to play with this a little bit. You can do a little bit of the math, not much. And you're going to look at pH of various things. I pulled up for you the colors that the cabbage indicator gives you at various pHs, and I pulled up some data from some household chemicals, and you can line those up and see what the pH is. There's a section in the data that says using pH paper. I didn't get any data for that, so you can just cross that out. And like I said, if you have purple cabbage at home and you want to cook it up, you can try some household chemicals yourself. Just put a little bit of the cabbage juice in the liquid and you can see it. That's pretty much what you're going to do. There's also some questions about acid rain, but we dealt with that in experiment 4. So you can look that up. And that's basically everything you need to know to actually do this lab. And as always, I'm available on Zoom. So have fun doing this. And by the way, there's no quiz for this lab. We're done with quizzes.